Hello everybody, welcome to the Cumulative Review 14 videos that goes through every question in detail. So let's go. Number 1, rewrite log of x equals 2 in exponential form. So if I want to change this into exponential, the first thing I need to think about is what is my base? When I see a log, you assume that the base is 10. So if I'm changing to an exponential, it would be 10 to the, remember, logs equal exponents. So this 2 is my exponent, and that must equal x. So this would be my answer written in exponential form. You could also write it as x equals 10 squared. And yes, that is x equals 100, but I'm leaving it in this form because you want to see it as an exponent. Number 2, rewrite e to the x in log form. So if we're going backwards, we need log base something equals my exponent. So in this situation, my exponent is x, so that has to be over here. So technically we have log base e of 8, but log base e has a better name, and it's ln. So it's just ln of 8 equals x. You also could write x equals ln of 8. Number 3, evaluate. So I'm evaluating all these logs, and remember, logs are exponents. So your answer for all of these will just be an exponent. And to think about it, what you're really thinking about is this. 3 to the what is 81. So 3 to what power gives me 81? That power is 4. So my answer is just 4. This is asking 2 to the what is 1/8. Well, 2 to the third is 8. So 2 to the negative third must be 1/8. So my answer is just my exponent of -3. And then part C, 5 to the what is 1. Well, anything to the 0th is 1, so this exponent must be 0, so my log answer, or my exponent answer, is 0. So on your test, if you just see me asking what is the log, remember your answer has to be an exponent. Condense the log equation to a single logarithm. So condense, we want to make this smaller. So I notice that all the logs have the same base 10. I also notice that every single one of these has an exponent. So the first thing we want to do when we condense is move all of the exponents, move all the lead coefficients to become exponents. So we'd have log of x plus 1 to the 1/4 minus log of y minus 2 to the 9th minus log z to the 3/4 power. So that's step 1. Step 2 to condense is to think about our log rules. If we have 2 logs being subtracted, these arguments are going to divide. But we are actually subtracting 2 logs, which means both of these arguments are being divided. So we're going to make it into a single log. The x plus 1 to the 1/4 is going to remain in the numerator. And then if we are condensing it, the y minus 2 to the 9th is going to multiply the z to the 3/4 in the denominator. So now it's at least a single log. And the last thing we need to do is simplify these roots into radicals. So we'd have log of, so 1/4 means a 4th root. So on the top, we have the 4th root of x plus 1. Then we have y minus 2 to the 9th. And here, this is some nice review here. This really means the number on the bottom, again, represents the root. So we have a 4th root of z, but this 3 means that I'm raising z to the power of 3. So it would be the 4th root of z to the 3rd. So this is my final answer because everything's written as a radical now, and we have a single logarithm. Just for the sake of review, if you see something like x to the, 2/3 power, if I want to convert that into a radical, the 3 is the type of root, so this would be the cube root of x raised to the 2nd power. So just thought I'd throw that in there as well. Number 5 here is doing the opposite, asking you the opposite. Expand the log expression using all properties possible. So we first want to think about getting this to be all separate logs. But I notice we have log base 4. All of these things are underneath the square root, which really means all of these things are being raised to the 1/2 power. So the first thing I'm going to do is keep these in the top, keep this on the bottom, but raise all of them to the 1/2 power. The reason I want to do that is because if we are expanding a log, we want to bring the exponent down in front. So we have 1/2 log base 4 of all of this in the argument. So now we want to start expanding. If we have two terms multiplying on the top, we're going to have two separate logs being added, and if we are dividing by something at the bottom, that log is going to subtract. But this 1/2 affects everything. So it's 1/2 times log base 4 of x cubed plus, because we're multiplying on the top, log base 4 of y to the 6th. Then the z, we're going to subtract log base 4 of z. The next thing we want to do is bring the exponents down front because we're still trying to expand. This 1/2 is still hanging out in front though. So we have 3 log base 4 of x plus 6 log base 4 of y minus, technically there's a 1 there, but bringing that down makes no difference. So log base 4 of z. The last thing we need to do is distribute that 1/2 to every term. So 1/2 times 3 gives me 3/2 log base 4 of x. 3. That's a terrible 3. Plus 6 times 1/2 is really 3 log base 4 of y minus 1/2 log base 4 of z. And just for bothering me, I'm going to try to make a better 3 there. So this is my final answer, expanded out. Log equations and exponential equations. So, number 6, I notice that this is an exponential equation, and we may need to change this to logs, but first, let's think about these bases that were given. Can I write those bases as the same base? Can I write something to a power? Well, 8 to the first is 8, 8 squared is 64, so we jump right over 32, but we could write 8 as a base of 2. This can really be 2 to the third, and then 5x plus 1 is still in the exponent. Can I also write 32 as 2 to a power? Yes, I can. 32 is 2 to the 5th, and then multiply by x minus 3 in the top. Because when you're raising power to a power, you multiply the exponents. So because these bases are the same, the exponents must be equal. So we have 3 times 5x plus 1 equals 5 times x minus 3. So we have 15x plus 3 equals 5x minus 15. Move the x over. We have 10x over here. Subtract that over equals negative 18. Divide by 10. So x would be negative 18/10, which is better written as negative 9/5. Feel free to plug negative 9/5 back into both sides. If you do, you should get the same answer in both. And you can do that completely in your calculator. Number 7. Again, this is an exponential equation, so it's possible that we might need to change these to logs, but the first thing we need to do is isolate the exponential part. So we need to get rid of the 1 first. So we have 3 times 7 to the x minus 7th power equals 39. Now, again, I mentioned this in a previous video, but I want to mention it again here. It's really tempting to want to multiply these and make it 21 to the x minus 7th. But the 3 and the 7 are both not regular numbers. 7 is a base. So we can't multiply a regular number times a base. Instead, what we need to do is isolate the exponential piece. So we need to divide both sides by 3. So we'd have 7 raised to the x minus 7 power equals 13. Now, this problem reminds me a little bit more of this one, that we have a number and a number. Can I write both of these bases as the same number? Can I write it as like 2 to the third and 2 to the 5th? Well, 7 to the first is 7, 7 to the second is 49. So we skip right over 13. And there's no way you can write 13 in terms of 7. So no, we can't. So this is an example where we need to change from logs, or from exponents to logs. That's their inverse relationships. So what I'm going to do, again, is either apply a log on both sides or apply ln on both sides. I will choose ln for this example. So if I apply an ln on both sides of my equation, what I can do is bring the exponent down in front. So we have x minus 7 all multiplied by ln of 7 equals ln of 13. And as I've suggested previously, I would suggest dividing both sides by ln of 7 because all of this is multiplying x by 7. Really helps get the variable isolated. So you have x minus 7 equals ln of 13 divided by ln of 7. Let me rewrite that just to be a little bit more clear. That should say ln of 13. Then the last thing we need to do to get x by itself is add the 7 to the other side. So my answer in exact form is ln of 13 over ln of 7 plus 7. Now it's important though also to know what your answer is to the nearest thousandth. So what you would do is take ln of 13 in your calculator, divide it by ln of 7, press enter, and then add 7 to that result. If you do, the answer to the nearest thousandth would be 8.318. Feel free to check that. Number 8. We have two separate logs on the same side of the equation, not equal to a log over here. I would suggest combining these two logs or condensing these two logs. Both of them have the same base, so we can condense them to be log base 8. When you're adding two logs, you multiply the arguments. X times x plus 12 equals 2. So what that really is log base 8 of x squared plus 12x, if you distribute, equals 2. So now, we don't have log equaling a log, so we can't set this equal to 2. But what we can do is change this equation from a log equation to the inverse of an exponential equation. The base of this exponent is going to be 8, and the exponent is going to be 2, and that's going to equal x squared plus 12x, which is the argument. So we have 64 equals x squared plus 12x. 0 equals x squared plus 12x minus 64. Factor this. 16 and 4. Positive, negative. So two possible answers are negative 16 and positive 4. However, as we've discussed, the x values cannot be negative, because if I plug negative 16 back into the original, you have log base 8 of negative 16 and log base 8 of negative 4, and we cannot have negative values in our domain. So the only answer is just going to be x equals 4. And if you take 4 and plug it back into the original equation, both sides should equal 2. Last equation for this page here. If we have two separate logs being subtracted on the same side, we can make our lives easier and make it into a single logarithm, ln, but your arguments, if you're subtracting or dividing. So it's 5 over x plus 1 equals 3. In a similar way to number 8, we can change this from a log equation to an exponential equation. The base of this log is technically e. So if we're changing it to exponential, my base is e, my exponent is 3, and that's equal to 5 over x plus 1. So if I continue to simplify this and solve for x, this is really e to the third over 1. So I can cross multiply here. So we would have x plus 1 times e to the third equals 1 times 5, or 5. And I'm trying to solve for x. So what I would suggest doing is dividing both sides by e to the third. Make your life easier, not harder. So you have x plus 1 equals 5 over e to the third. And then to completely isolate x, we would subtract both sides by 1. So your answer is an exact form is 5 over e to the third minus 1. If you plug this into your calculator, again, please be careful to put this in parentheses. 5 divided by parenthesis e to the third, enter, minus 1. The answer that I got was x equals negative 0.751 to the nearest thousandth. All right, guys, that's it for this video. We will continue with number 10 on the next video. Thank you.